Hi friends, in this video we are going to look at problem 1550, 3 consecutive odds, and in the next video we are going to explain a problem using backtracking. So this is the first video. So here we are given an integer array. We want to return true if there are 3 consecutive odd numbers in the array. Otherwise we return false. So if you look at the length, actually the length is bounded above by 1000. So this is a small size problem, and also the logic is rather straightforward. Therefore, this is an easy one. But here our goal is to first we practice a brute force solution. So actually, for some problem, so if you can write brute force solution, it actually demonstrates strong coding ability rather than writing with the optimal solution, right? For example, some problems you can write it using recursion without knowing too much details. However, writing using brute force can be strictly a little bit harder, right? This is what we mean. Another one is that we can use a second solution, mimic a queue behavior. So this will be our goal here in this video. First, I'm going to write the brute force solution. So given length, the length will be just right here for convenience. So here, the problem requires there are at least 3 consecutive odd numbers, but the length can be 1, can be 2, right? So we need to first do a check. If n is less than 3, so we just return false because there's no not sufficient elements. So next, what we are going to do is this. So we can do for I in range. So if you have the first one, the index will be 0, 1, 2, right? Therefore, indexed from 2 to n, right? So I'm just going to directly check if array I modulo 2 equals 1. So you can write like this, or you can write like this. So this way of writing is more explicit. In other words, increased readability. So I'm going to confine with this one. So array I minus 1 modulo 2 equals 1, and array I minus 2 modulo 2 equals 1. So here this if condition is valid, is a right syntax. The reason is that here I is greater than or equal to 2. So then the smallest index in this window is I minus 2, which is greater than or equal to 0, right? Then if this were the case, we're going to return true. So after this for loop, if nothing has returned, so we're going to return false. So this is the one way of doing this problem. Let me first run it. And yeah, it passes all the cases. So next, I'm going to write another version. So the other version, so we are going to first get one of the 3 elements, and then we are going to use a window, fixed window, that is set 3. So I'm going to change this one to be version v1, and I'll copy this part. This is the edge cases check. So now I'm going to first get the window sum. So if the 3 consecutive element are all odd numbers, so we should have in sum 3. So in the sense of modulo 2, right? So we have array I modulo 2 equals 1 for I in range 3. So here we write range 3 because the index involved is 0, 1, 2, right? So this is the one. So we can first do a check. If window sum equals 3, so then we just return true, right? So otherwise, we are going to consider the next element, add to the window, and then pop the earliest one, right? So basically, it's something like this. So for I in range, so we should start from index 3 ending at index n minus 1. So the window sum, so the number at index I will be in the window. So it will be array I modulo 2, check if it equals 1. So you can write it like this or add a parenthesis. So I guess this is more readable. So then the oldest one, or the earliest one, that is array I minus 3, right? So modulo 2 equals 1. So this should be minus. If it's a odd number, we should exclude that because we consider a fixed window of set 3, right? So we can do a check. If window sum equals 3, so we're going to return true. Then otherwise, we're going to return false if we haven't got anything returned yet during the for loop. So let me check it. Yeah, it passes the 2 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So I guess that's basically about it for the coding part. So here, let me make some comments. The first one is that, so for this easy problem, it should be very familiar, and also it can be used to practice some advanced concepts like data structure and algorithms, because the logic is simple, so you can typically run it manually so that you know what's exactly going on. So with that said, I guess that's it for the current video. Thank you for watching.